ठीक है Mr. Simang, chapter 1 physics force. First question, बोलिए.
Produce a moment of force of 1575 dyne centimeter when the perpendicular distance between the point of application of force and turning point is 45 centimeter.
Okay, कैसे करेंगे?
Force 0, 45 dyne centimeter. Or perpendicular distance 0. The moment of force will be equal to force into perpendicular distance.
Moment of force. Moment of force is also called as torque. So moment of force की जो definition है वो आपकी बुक में लिखी हुई है यहाँ पर. अब इसमें दो तीन चीजें आप ऑब्जर्व कीजिए. ये देखिए, the moment of force or torque. So the first question is कि moment of force is also called as torque. So this can be a MCQ. Is equal to the product of the magnitude of the force and perpendicular distance of the line of action of force from the axis of rotation. The line of action of force, Mr. CB, क्या है?
Line of action of force मतलब आप
शाबाश. So imagine आप कीजिए कि this is a door that you have. So we are looking this door from above, and this is the axis of rotation. This is the axis of rotation, and this is the door. अब imagine कीजिए कि आप जो force लगा रहे हैं, that force is in this direction. तो force जो है वो ऐसे लग रही है. Now if you try to understand the line of action of force, the line of action of force would be something like this. Mr. CB, समझ आया नहीं आया? So this is the line of action of force, and this is the perpendicular distance between the axis of rotation and the line of action of force. This is the perpendicular distance between this is the axis of rotation. So this distance would be this is the distance which is being talked about, this distance P. So moment of force is equal to, this is the perpendicular distance. Moment of force is the magnitude of force, because force is a vector quantity. So we need to take the magnitude of the force. So magnitude of the force multiplied by the perpendicular distance between the line of action of force. This is the line of action of force, and this would be the perpendicular distance. Mr. Sivang, any doubt? Now, so in this example, the question is pretty simple. We have been given the moment of force, which is a torque, which is equal to 1575 dyne centimeter. We are given the distance between point of application of force and the turning point, which is 45 centimeter. So this question is very simple. And if we want to look at the solution, this is the solution. So moment of force is called the torque. Torque is 1575 dyne centimeter. Force we want, and the perpendicular distance is 45 centimeter. So force would be equal to 35 dyne. Now, Mr. Sivang, what is the relation between dyne and Newton?
About 5 dyne is equal to 1 Newton.
Dyne and relation. The relation between dyne and Newton. See, dyne is a CGS system. So here we have centimeters, we have grams, we have second, and Newton is MK system. Here we have meter, we have kg, we have second. Now if I take Newton, 1 Newton is equal to 1 kg into 1 meter per second square. This is equal to 1000 grams into 100 centimeter upon second square. So this will be 10 raised to power 5 gram centimeter per second square. And this quantity, gram centimeter per second square, is called dyne. So therefore, 1 Newton is equal to 10 raised to power 5 dyne. Mr. Sivang, any doubt?
No.
Great, sir. So now let us look at the second question. Second question is, okay, Mr. Sivang, can you read the second question?
Uniform meter scale is balanced at 60 centimeter mark when weights of 5 gram force GF and 40 GF are suspended at 10 centimeter mark and 80 centimeter mark respectively. Calculate the weight of the meter scale.
In all these questions, the best thing to do is have a rough diagram in front of you. So this is a uniform meter scale. So the total length of the meter scale, of course, would be 100 centimeter. Yeah. Now it is balanced at 60 centimeter mark. It is always better to mark the fulcrum. So this is the fulcrum, and this fulcrum is at the 60 centimeter mark. When weights of 5 GF and 40 GF are suspended at the 10 centimeter mark. So roughly this would be 10 centimeter and 80 centimeter. So 80 centimeter would be roughly somewhere around this. Mr. Sivang, any doubt?
No doubt, sir.
Now 5 GF is at 10 centimeter mark. This is 5 GF. The 40 GF is at 80 centimeter mark. This would be 40 GF. Is there any other force acting on this system, Mr. Sivang? Any other force?
Meter mark, there will be of the scale.
Because it is a uniform meter scale. So the weight of the meter scale would be at the 50 centimeter mark. And that is the unknown. I am denoting that by WGF. Mr. Sivang, any doubt?
No, sir.
Now, Mr. Sivang, how will we do this question? Okay, how will we form the equation?
10 into 5.
Okay.
GF,
Okay.
which will be equal to the weight on the right hand side.
Sivang, basically you need the distances from the fulcrum. This distance is 60 minus 10. This is equal to 50 centimeter. This distance is 60 minus 50 is 10 centimeter. This distance is 60 centimeter minus 80 centimeter, and this is 20 centimeter. Mr. Sivang, any doubt? So basically what I'm trying to tell you is that before you start attempting these questions, it is always better that you draw a figure, understand the situation, what is happening in the question, only then start the question. Just take 2 minutes more and draw a good diagram. Good diagram implies not a beautiful diagram, but it should be informative diagram. So this is what I've drawn. This is my fulcrum. And always remember that the distances, all the distances and these questions, they are taken from the fulcrum. Please remember that. And that is what I've done. This W is acting 10 centimeter away from the fulcrum. This is the fulcrum. This 5 GF is acting 50 centimeter away from the fulcrum, and that is why this 50 centimeter is drawn. This is basically the fulcrum, and this 40 GF is acting 20 centimeter away from the fulcrum. Mr. Sivang, have you understood the situation? Now please try to understand that we need to have a look at the turning effect of the forces. Now if we look at the turning effect of the forces, this 5 GF will try to turn this side. This W will try to turn this side. This 40 GF will try to turn this side. Mr. Sivang, any doubt? And please remember, again and again, you should be very clear that where is the fulcrum, because all the distances are as per the fulcrum. So the equation which is formed is 5 GF into 50. This is the distance 50. W, this is W into the distance 10 centimeter. And this is 40 GF, and the 40 GF is clockwise. This is clockwise. This is anti-clockwise. This is anti-clockwise. We want anti-clockwise to be equal to clockwise. Now 40 GF into the distance, this is a 20 centimeter. So this is the equation which is formed. Mr. Sivang, any doubt?
No doubt, sir.
And then we solve for W, and the final answer is 55 GF. Mr. Sivang, any doubt?
No doubt, sir.
And please remember, when you are doing these questions, that again, if we look at the units, then kgf or gf is a unit of force or weight. Please remember that. But kg and gram, they are the units of mass. Mr. Sivang, any doubt?
No doubt, sir.
Let's move on to the third question. Mr. Sivang, what is the third question?
A uniform meter scale of weight 50 GF is balanced at the 40 centimeter mark when a weight of 100 GF is suspended at the 5 centimeter mark. Where must a weight of 80 GF be suspended to balance the meter scale?
Again, before we start this question, we'll draw a rough diagram. So this should be a rough diagram with all the information should be put in the diagram. So a uniform meter scale of weight 50 GF. So we have a 50 GF. This 50 GF would, because it's a uniform meter scale, so the 50 GF would be acting at the 50 centimeter mark. Mr. Sivang, any doubt?
No doubt, sir.
Is balanced at the 40 centimeter mark. But please remember that this meter scale is not being balanced at the 50 centimeter mark. Please remember that. It is being balanced at the 40 centimeter mark. And that is why it is very important that you mark this fulcrum that this is 40 centimeter mark. Mr. Sivang, have you understood?
Yes, sir.
Okay. When a weight of 100 GF is suspended at the 5 centimeter mark. So this would be 5 centimeter. And you'll have a weight of 100 GF suspended here. Where must a weight of 80 GF be suspended to balance the meter scale? So let us assume that 80 GF is suspended somewhere around here. Mr. Sibang, any doubt?
No doubt, sir.
Mr. Sibang, how will we do this question?
We'll mark all the clockwise and anti-clockwise forces.
Okay. So this would be anti-clockwise. This would be clockwise. This would be clockwise. Mr. Sibang, what should we do here? 40 centimeter. Do we need to do something of 40 centimeter?
No, sir.
Because there is no force acting here. So please do not try to mess up this 40 centimeter. So you have to see the equation would be drawn something like this. So the anti-clockwise moments should be equal to the clockwise moments. There are two clockwise moments and there is a single anti-clockwise moment. So let us see the solution. Again, please remember that all the distances, they are marked from the fulcrum. So it is very important that you understand where is the fulcrum. So this is a diagram of the question. Let us try to understand. So we have 5 centimeters. So the distance from the fulcrum, again, distance from the fulcrum. Distance from the fulcrum is 40 minus 5 is 35. Distance from the fulcrum of this force is 50 minus 40 is 10 centimeter. This is the assumed distance from the 40 centimeter mark. Please remember that L is from 40 centimeter mark. Please remember this. Now, 5 into 100. I'm sorry, 5 into 35. No, I'm sorry. 1 second. So 100 GF into this distance 35. So 100 into 35. Yeah. So this would be the anti-clockwise moment, and 10 into 10. I'm sorry, 10 into 50. Yeah, 10 into 50, and then you have 80 GF, which is in the clockwise direction. 80 GF into L. So you'll solve for L, and the L would be 37.5 centimeter. But we need to remember that this 37.5 centimeter, this 37.5 centimeter is from this. This is 37.5 centimeter. So we need to add 40 to it so that we can know that this is 77.5. Mr. Sivang, any doubt?
No doubt, sir.
Let's move to the last question. Mr. Sivang, can you read the last question?
Calculate the length of the arm couple if a force of 13 Newton produces a moment of couple of 14.3 Newton meter.
Sivang, how should we do this question?
Moment of couple is given and force is given, and we have to find the distance. So torque is equal to force into perpendicular distance.
Mr. Sivang, let us first look at the. See, this is where the clockwise and the anti-clockwise movements have been discussed. Clockwise and anti-clockwise movements have been discussed in your book. And let us look at the definition of a couple. This is where couple has been discussed. Mr. Sivang, any doubt?
No doubt, sir.
So this is the formula that we need to use. The moment of couple is either force into perpendicular distance between the two forces. So the best example that you can take for understanding couples is when you are turning a tap. So let me draw the tap, which is old style. So this force would be this side, this force would be this side. Both the forces would be equal, and they would produce a turning effect. So you take either force, you multiply it by the distance between the two forces, the perpendicular distance between the two forces. Please remember that this whole distance is called the couple arm. So Sivang, any doubt?
Also.
So it's a pretty simple question. This is a formula that we apply. This is a formula that we apply. And now let us look at the solution. So moment of couple is equal to either force into perpendicular distance between the two forces. This perpendicular distance is called the couple arm. So we have been given the moment of couple. This is the one of the force 30 Newton into couple arm. So the answer would be 1.3 meter. Mr. Sivang, any doubt?
No doubt, sir.
Great.